I'll be going over the overall design of the Modular Bullpup automatic rifle. I've shown most of this already in my previous videos, but some of my viewers have said that it's kind of hard to see what's going on when I'm wearing gloves and, based on the camera angles. So I thought showing it through the 3D exploded view would be, more clear. So I've got my setup here with the OpenSCAD viewer and IntelliJ as my editor. I'm not going to be going into how I set up this assembly in this video because I covered that in a previous video. I'm going to start off with the overall design principles of this rifle, the trade-offs I've made, the engineering decisions I've made, and then I'll go into each sub-assembly in further detail as I have them loaded up here at the top. So first of all, the goal of this was to build a high-quality bullpup rifle that could rival mature designs such as the AR-15 for service use or just use as a recreational rifle for hunting or home defense or something like that. I know that there are a lot of bullpup designs out there, but in my opinion, they all have so many flaws that I myself am unwilling to use them for anything serious. I feel like they're just range toys. So first of all, I'm going to open this thing up. So I'm just gonna explode it. So now we can see what's going on inside of it. The modularity of this design is incredibly important. Notice that the magazine well is a modular component. This is for the Stanag mags. And then the dust cover is also modular. And then the fire control group, or the fire control module, is also a drop-in component. Technically, this isn't really considered a module, but the barrel assembly is something that allows you to pretty much use any barrel off the market, any AR pattern barrel, whether it's AR-15 or the DPMS pattern in this. So the goal of making this major design decision was to ensure that if you wanted to make a slightly altered version of this rifle for your very specialized use case, you don't have to start over and design a brand new rifle from scratch. You can use this as a platform and just change one or two things, right? And I've made it so simple in this case where you can just 3D print a new Magwell module. And, if there's some new magazine in the future, then you can just very quickly adapt this rifle to use it. So I'm gonna show you some of the other variations of this, some of which I've sort of teased on my YouTube channel before. So this is for the AR-15 configuration. The DPMS variant is configured for the sniper's configuration with a longer barrel, and the DPMS magazines, obviously. I have a sniper variant handguard, so it's basically just a bit longer, giving you a bit more rail space to mount stuff on. But one important thing that I did for the European market was to make this compatible with AK pattern magazines. So as you can see, AK-74 and AKM magazines work, and they have their own Magwells that I've already made. The reason I did this was specifically for the Eastern European market. As you know, the war in Ukraine is currently ongoing. A lot of the design considerations of this rifle was made with logistics in mind. If a country that is close to Europe, close to Russia, like Poland, for example, If they get cut off from NATO supply lines and their factories get destroyed, they can just reconfigure all of these rifles, if they're using them, to just use, Russian ammunition and Russian magazines, and then they can just quickly and easily resupply off of captured enemy supplies. And then the last configuration is for the 6.8 Magwell. I actually don't have a magazine for it yet, but this is for 6mm arc, and with 6mm arc, the problem with Stanag the problem with Stanag magazines is they don't feed reliably. So a lot of companies got together. I think Magwell is making a new magazine for the 6.8 pattern. I think they call it the ICAR. And a lot of people online are saying that they don't like this decision because they don't want to have to make a new lower and build a brand new rifle to support that. And the great thing about the modularity in this design is you don't actually have to build a new rifle. You can just 3D print another Magwell, and your rifle is good to go with the new magazines. This actually took me less than 5 minutes to design because I had all the OpenSCAD code parameterized. So once I got the measurements, I simply just edited the Stanag Magwell and then built this. So it was super easy to do. 5 minutes on the computer, and then I just waited about 2 hours for my printer to print it out. So that's what we have there. There's a lot of considerations I've made in here for both the military and civilian markets. Because a lot of people are very familiar with the AR-15 pattern rifles, I made sure that the controls are exactly the same as an AR-15. So you got your safety here. This is a 45-degree throw, which is becoming more popular. The mag release is right here, and the bolt catch is above it, the exact same positions. I've also labeled the controls just to make it more obvious. The bolt catch gets moved back and forth like this instead of like pressing the up or down part of it like on an AR-15. And the reason why I did that was because even with like ambidextrous builds for the lowers on an AR-15, the controls are not the same on both sides, which was a huge frustration for me since I am left-handed. Every time I switch to my right hand, I found that I have to remember that the control is different on the other side, even if it's supposedly ambidextrous. So on this one, I've made sure to not only make it sure it's ambidextrous, but to make sure the controls were symmetrical on both sides. So you don't have to remember that it's different one way or another. It's simply just the same. You don't really have to remember anything. So I'm gonna go into like each detailed sub-assembly now, and then just kind of show you how each part interacts with the other. So for the upper receiver, here I have it exploded. So this is actually not the upper receiver I've built currently. This is the optimized version that's meant to be cheaper to manufacture, and it's optimized for aluminum extrusion. So in this version, I have the rails separate and screwed in from the side, the bolt carrier rails and the cam guide. And the reason why I did that was so that you could make the upper out of 6061 aluminum instead of 7075. That will dramatically reduce the cost because 6061 is much softer and easier to machine. And then you can just use like tool steel or alloy steel for the rails. And of course, these are wear parts, right? So at some point you're gonna want to replace them. So, it's easy to do if you do that. I also made the Picatinny rail on the top screw-in. So hopefully that reduces the cost a little bit. But other than that, it's pretty much the same upper that I have now. Moving on, I don't think I've gone into too great detail on this, but these are the linkages for the trigger and the safety. So the one right here is for the safety, and the one on the right side here is for the trigger. Those go into these guide holes right here, and those springs are sort of to keep the safety pushed back. And then this one right here is actually optional. I'm not really using this in my build, but this is to just give your finger a little bit of assistance if the trigger is a bit heavy. So again, that's optional. You don't have to use it. And I'll get into this a bit more in detail later on. And then we have the handguard in the front. Pretty simple. It's just one piece, and it screws in on the side into the upper receiver. There are 4 alignment knobs to make sure that this thing will hold 0 if you got like a laser on the front. So yeah, that's pretty much what that thing does. I'm gonna put this thing back together so I can show you how the linkages work. So the trigger in the lower pushes the linkage here backwards, and then there's another piece in the lower right here. Let me put this back together. So the safety, when the safety is removed, this thing gets pushed up, and then that is what causes like this sloped angle in the bottom here for the left-hand side linkage, the safety, to be pushed forward. And that is what allows this right here to move forward, allowing the safety plunger to be depressed. The trigger linkage is pretty simple. It just gets pressed right here, and this is where the fire control module gets screwed into on the side. And I'll go over the bolt carrier next so you can see what exactly is going on over here. So here is the bolt carriers. I have 3 versions. The one in the middle is for the AR-15. Any AR-15 bolt and bolt cam will go into it. The one right here is for the DPMS pattern bolts, and it'll use the same cam pins as well. And each one has their own like feed lip geometry at the bottom here. The one right here is specifically for the AKM or the AK-47. It's basically the same as this, except it has the feed lip pattern that's found on here. And the reason why is because it's a 30 cal, so the feed lip geometry is a bit different. Over here we have the safety plunger. That spring is held captive and it basically keeps it pressed out. So this needs to be pressed all the way inwards and depressed so that the striker can be pushed forward. This is pretty much like the rear of this is pretty much the Glock design, except I've made like 2 modifications. So let me put this back together, or at least one of them, so I can sort of show you how it works. So let's put the AR-15 one back together. So this is pretty much the same as a Glock. When the trigger gets pulled, this gets depressed, pushed inward. And then this on the side here is for the manual safety, which a Glock does not have. So this will make it drop safe and just give you that extra sense of security. When the linkage that I demonstrated in the previous the previous model right here, like that. This moves forward, right? So that is what creates enough negative space for this plunger to move into. Because when the safety plunger, or when the safety is on, it's physically, there's the hole that this thing is going into is physically being blocked. That will prevent you from depressing it, and will prevent the striker from going forward no matter what. So that's just an extra level of safety I added. The other thing is the buffer system. So this was actually feedback that I had gotten from the community. So since this is constant recoil, it's not supposed to touch the rear of the stock plate. But if it's overgassed, it could still hit it. So I figured, since I already have a pretty powerful striker spring right here, I might as well just use it to, use it for the buffer spring. So basically this thing will reciprocate, and when after this thing is fired, or when it's not in battery, the striker is going forward. So you can push this all the way in, and it will stop itself on the face of the bolt carrier right here. So I just figured I would dual purpose it, since I already got that spring in there, and then I don't have to use additional parts in this thing. So the recoil spring goes in up here. That hole in the front is for the recoil spring to sort of fold in on itself, and at a certain point it has to go through it, because the recoil spring needs to fold into 1/3 of its original size. And I got the recoil spring right here to just show you how it works. So it's pretty simple. You just got the front part, you got the main body, and this is the part that sticks out through that hole I just showed you. And then there's a cap at the bottom. Roll pin goes in to keep it captive. Pretty simple. Nothing revolutionary here. So to accommodate the downward ejection, I had to move the fire control module internal and have it interact on the side here. The reasoning why was because the top part is taken up by the charging handle, and the bottom is taken up by the with the magazine. The the right side is taken up by the cam pin, so that only left the left side as to where I can move the fire controls. So if I go back to the complete model here, give it a second. So if you look in the lower here, where the ejection port is, that's typically where your hammer and fire control group on an AR-15 is. So I had to remove it from this spot to make sure that there was some space for the ejection. So moving it to the left side was just the logical option. So the reason why that the cam pin's down on the right hand side is, as some of you may have figured out, the bolts, this is a standard AR bolt, and this is normally on the top. Normally it ejects out to the right side, and I want it to go down. So I'm gonna move this to out of battery. So you can see that this is rotated to the out of battery position. And at this point you can see the extractor and the ejector are oriented in a way where it goes down. And that's why it's on the side. This cam pattern is exactly the same from the AR bolt carriers, just copied it exactly. So yeah, that's how it works. This little hook in the front is for the forward assist. I'm gonna go over that in the charging handle right here. So this latch right here, it's got two of those Glock safety plunger springs that I'm using everywhere, and it just allows it to rotate on this roll pin right here. So then this right here is the angled slope. So sorry, wait. If I open up the upper again, you can see that there's a slope right here, and that's to disconnect the forward assist latch when it's in battery, so that the bolt carrier can move freely at that point. Other than that, the charging handle is fairly simple. I've got folding charging handles, so I'm using these ball plungers as detents for the folded and unfolded positions right here. And these parts right here are the same, so they just twist in opposite directions when it goes into that like little key-shaped slot, and then that's what keeps it in. So for the downward ejection, there's only one other design that has done that, and that is the RDB by Keltec. So a major design flaw in the RDB is there isn't an ability for you to clear jam because the ejection port has been moved. So like this is the ejection port here. Like there's no way for you to see if the weapon is loaded, and there's no way to clear jam. So I added an auxiliary chamber inspection port at the top here. And this is what allows you to, do all the other things that you would on a normal rifle, such as clearing a jam and seeing if it's loaded. Also labeled it to make sure there's no confusion. So basically the ejection port has sort of been split in two. This one is to actually eject, this one is for the service port aspect of it. And I've got a few renders here to show you what it looks like. I've also shown it like in some of my videos, but here it is from the side, and here's looking in down on the chamber, and here it is, you can see the bolts. So this black thing right here is actually the charging handle. The charging handle is non-reciprocating, as many of you have noticed. And because of that, the charging handle is what acts as the cover for this port. So it stays closed while you're while you're operating the rifle, and it'll only open up when you pull the charging handle back manually. So yeah, so that's how the charging handle works with the bolt carrier. So I think at this point I've explained the bolt carrier and the upper receiver in more detail, or as much detail as I can. And I think the only thing left at this point is the barrel assembly and the fire control module. So let's go over the fire control module next. So this is the fire control module. The housing itself is 3D printed. Also labeled it to have no confusion. It screws in from the side, as I've shown you earlier. So this is what it's like when it's disconnected, when it's all disassembled. This is the sear that actually holds back the striker until it's ready to be fired. And then this roll pin just kind of keeps it captive. That's what that little nub on the back sticking out is for. This right here is the disconnector guide. This little slope is to depress the safety plunger, and then these are the springs for both. So like this will push the trigger back, obviously give you a bit of weight, and then this is the disconnector itself. So when I pull this all together, I think you can see a bit more of how it works. So I'm gonna, all right, so this will slide forward. It will get pushed by the trigger linkage. And then this disconnector here is what actually pushes this inward, or pushes this thing inward, so it goes down or deeper into the housing, based on like this sloped surface right here and right here. And the reason why I did it this way is so that your trigger is not actually fighting against the force of the striker, as you would on a Glock. That's what increases the weight, right? So I was able to get this down to a 4-pound pull. And I think that's pretty good, since I think like match grade triggers are typically around 3.5 pounds. So, you know, because, you know, this thing moving inward, you're just fighting the force of that spring and this spring. Effectively, it's not like you're not fighting the force of the much heavier striker spring. So this right here is the disconnector, as I've said, and this will rotate on this roll pin inside. So when the bolt carrier moves back, this surface right here is for the disconnector, and it pushes that thing down, forcing it to rotate. Let me show you here. So it pushes this little plunger down, causing it to rotate. And at that point, this thing will move up, and it will release the striker sear, allowing it to go back up and allowing it to catch when the bolt comes back into battery. So again, like, this is a drop-in fire control module. Like, you don't have to do it like this. I was planning to open source this, or just kind of like let the aftermarket figure out if they could build a better version of this. This is just like what I came up with on how to do it. So yeah, that's basically it here. Now we're moving on to the barrel assembly. So I've got two here, and one is for an AR-15 pattern barrel, and the other is for DPMS pattern barrel. So basically, I just have two of these front and rear half adapters for the barrel mounts. Each one is held in with 8 screws that go into the side of the upper receiver. That's what this right here is for on both sides. So there are also 4 tensioning screws on each one. That's just to keep this very tight. Still, you'll have a very accurate stiff mount, so you're not going to have any problems losing zero. And I've also stuck some shims in mine right here to just give it like, you know, the maximum like tightness. So yeah, like basically because of this, you can use any AR-15 or DPMS pattern barrel and bolts. So like if you want a carbon fiber barrel, or if you want a match heavy flute match grade barrel, or even a pencil barrel, like you can do it. All the new fancy cartridges that come out typically will come out in like one of the AR patterns, whether it's like 6 arc or 8.6 blackout or 300 hammer. Like you can pretty much rechamber this rifle to be in like any cartridge you want. You just have to maybe like tinker with the gas system and the recoil spring a little bit. On the front here, I've got just, you know, a typical gas block and like a short stroke piston. There's really nothing special going on there. I built my own because the distance between these two holes has to be exactly 22 millimeters. But other than that, it's, you know, standard AR gas block that, one of the proprietary piston manufacturers like Superlative Arms or something would make, right? So like, if you're watching this video, 22 millimeters, that's the distance from the centers. If one of you guys wants to make one, go for it. You can DM me, I'll send you the length that these rods need to be. So yeah, that's pretty much it for this. So let's move on to the lower receiver. All right, so we got the lower receiver here. I've shown this before on camera as well. This can be made out of polymer. I mean, most of it can, except for like a few parts in the rear plate, obviously. So I'm gonna open this up. So as you can see here, I've added this ball plunger again for a detent, and that's basically what keeps the takedown pin captive. There's only one takedown pin for this design. Now it's captive, so can't lose it. The front of this, or I'll just move from rear to front here. These right here are the hooks to have this thing mate with the upper receiver. Let me show that to you quickly. Complete. So there's two right there and two right there. These two correspond with the ones in the front, and the ones in the back go right there. So the ejection port is right here. This right here is for like the QD to screw in like a M-lock QD mounts, or you can use like any sling mount you want actually, or even if you like, you can even probably move it further into the rear if you want. I forgot to mention there's like a storage pocket here, very standard for like any modern rifle. So yeah, you can move this like M-lock footprints anywhere else you want around here, but I just prefer mine right there because that's usually the position I have it on an AR-15. So this right here is the ejection port accessory footprint. I decided to make the dust cover or the brass catcher modular because not everybody needs either of those two things, but some people do. So like for a more budget version of this rifle, you don't actually have to put like a dust cover on it. Let's say if you're just using this as a home defense rifle, it's unlikely it's going to get dirty or jam up or anything. So you don't have to put anything on it at all. So the dust cover is right here. So this is the rod that the upper receiver, or I'm sorry, the bolt carrier in the upper will hit. That causes it to rotate, and that pushes this thing open. I can show you this quickly. Dust cover. And this is it closed. And then this is how it opens up all the way. Yeah, there's just roll pins for the hinges. I'm using the ball plungers again for the detents that go into like those holes right there. And then there's a torsion spring that I don't have pictured here, but if you watch one of my earlier videos, you can see this in more detail. Also got the brass catcher here. So this thing will open up on the bottom. There's like a sliding bottom trap door that allows you to empty it. And basically the idea is, since you have this this common pattern, you can make like any accessory that will go over that will attach to the ejection port. So if you want the brass to get deflected in a certain direction, maybe like slightly forward, slightly to the left or right, you can also 3D print an accessory for that purpose. So moving on to the Magwell. So this is the pocket where the magazine well gets dropped into. This was a big feature that I wanted to include so that you could pretty much use like any magazine out there, like the Leo mags, like whatever. It's up to you. So the thing that I did differently versus all the other Magwells is that since this is a Bullpup, I wanted to have forward linkages. So these two hooks in the front will catch onto the hooks in the front here. So let me just push one of these together. Let's take the SR25 one and assemble it. So when you drop it down from the top, these hooks right here will go into these hooks right here, and this one will only move backwards by about 4 millimeters, and that's what causes the magazine to drop. This one will move forward and backwards, so plus or minus 4 millimeters each direction, 8 millimeters total travel. So when it gets pushed back, it causes the bolt carrier or the bolt catch to go up, and then vice versa, right? So you can see that in the exploded version of the complete rifle. So you can see that they line up here, and they basically just go down in. So since I got the exploded here already, these two springs right here are the Glock magazine release springs, and they go into the bottom here for both, and then the other side goes right here, and that's what allows this thing to go forward and backwards. This thing only backwards. So I figured it was a fairly simple. The motion of this was fairly simple to the magazine release spring on the Glock, so I figured I'd just use off-the-shelf parts for that. So the safety here, I've sort of gone over this. So the primary purpose of this is to stop the trigger from being pulled and to move this linkage, this like safety bar up. So like there's a hole right in here. That's for the roll pin that goes into there, and it's just like a thing that sticks out. So when this thing rotates, it pushes this thing up and it causes the linkage to move forward. Other than that, it's a pretty standard safety. I'm using the ball plungers again as detents that screw directly up from the bottom, this roll pin will keep it attached from the other side, fully ambidextrous, of course. So yeah, that's all there is to it there. The front here, I've got the mag release. That's what pushes this little spoon backwards when it gets pushed in from either side. And then this right here is the bolt catch. So this is angled right here, just making it easier for your finger to push and grab onto it. That just goes in that hole here, and it just allows you to move it linearly forward or backwards. And then at the bottom here, I got like your standard like AR-15 pattern like grip interface. So any standard AR pattern grip will work on this. I would recommend a straighter grip. The reason why is because with the AK-47 magazine, it's a bit more curved and there's not a whole lot of space here, so you just want to make it a bit straighter. Going more in detail on the magazines or the Magwells, so I've built 5 of them total so far. The Stanag DPMS, or the SR25 and the Stanag and the 6.8 are pretty much the same. So you got like the left hand or the right hand side as the bolt catch linkages, and this you know, as I said before, when this gets pulled back, it causes it to go up, and then when it goes forward, the hook causes it to get pulled down. There's a spring here that keeps it down, and then you got your rear bolt catch, like a backup button. For the mag release, it's pretty much the same thing. You got your mag release backup in the front in case the linkages fail, and it just pushes this thing out, allowing you to release the magazine. There's a spring here that keeps the magazine release on this hinge like pushed forward usually. So yeah, that's pretty much how these three work. For the AK Magwells, it's a bit different. So I don't have a bolt catch on these because most of the AK magazines just don't support it. I've got your backup. This right here is for the backup mag release, you know, again, in case the linkages fail. And then this is for the rear lug, and this is for the front lug. So this one just kind of rotates out of the way. When this like nub right here gets pushed rearward, it causes to rotate on that hinge and moves this thing out of the way. It's also sloped in the front here so that that lug will push it inwards. For the back, it's also sloped, and this one is it's held in with like two Glock springs that go into the rear here, and these two basically just push it backwards. So like these two are pretty similar. They function the same way. All the small parts in it are interchangeable between the two. It's just the geometry of this Magwell is just a bit different. But overall, the AK mags are fairly similar in geometry. So, you know, once I made one, the other one was fairly simple to do. So yeah, all these are 3D printed. The AK ones are 100% 3D printable, like the linkages and lugs. You just gotta buy the spring and the roll pin. The AR ones, you know, these two parts need to be made out of metal, or sorry, these three parts, the bolt catch, the linkage, and the magazine release. This one can be made out of polymer. Oh, and the button right here has to be made out of metal as well, because this hook will break if you pull it too hard. So yeah, I think at this point I've covered every major sub-assembly on this thing. Total parts count is about 121 in the minimal case. And I think half of them, more than half, about 60% can be bought off the shelf, and with the remainder it's like 20 and 20 polymer and metal respectively. So yeah, other design considerations, I wanted to make sure that the surface of this was extremely smooth and there was no snag points. That's a frustration I had with the AR-15 with the forward assist and the brass catcher. I've like, especially when you're operating at night, I've done like many hikes and many night shoots. So, you know, when you can't physically see your weapon and then it gets snagged on your plate carrier or your chest rig or something, that's actually incredibly annoying. And I've also, I just, you know, made a clear point to keep the surface as smooth as I possibly could to eliminate that scenario. I've also slept with my rifle before. I didn't wear a plate carrier, I was just wearing a chest rig. And when I had this thing against my chest, keep in mind I'm left-handed, the brass deflector and the forward assist like kind of poked my chest. So that was another reason I wanted to make sure this thing was, you know, as smooth as possible. So yeah, other than that, you got a free float barrel here for the maximum possible accuracy. I've gone over in other videos why I decided on a short stroke gas piston, so watch that video if you want to find out more on the engineering trade-offs I made there. And as for downward ejection, that was a non-negotiable feature for this design. The reason why is because uh, I I am left-handed, but if you want to, like, I think that ejecting it to the other side doesn't really work because you have to switch sides fairly frequently in CQB, and you can't pull out your tools to reconfigure your rifle, like with the Tavor or the Desert Tech designs. So downward ejection is just the way that you can get this to it's like the general solution, right? That works in like every situation. So that's why I did that way. And then the unintended benefit of the downward ejection system is that now you have constant recoil. So typically, like, your typical bolt carrier will only move to like here, but this thing has to move twice the distance or twice its own length to eject downwards. So I got an image rendered here of the ejection. So because it has to move so far, it has more distance to slow down, and because of that, like, if it touches the rear at all, it will be very slow then. So most of the recoil, as you know, from semi-automatic firearms comes from the bolt carrier slamming into the rear. With this, I'm able to eliminate it completely, assuming that you have the gas system, the springs, all tuned and stuff, which allows you to have, just faster follow-up shots. So yeah, that's how that works. And I think at this point I've covered every single design feature of this thing, all the engineering trade-offs I've made. There is one other question that I've been getting from a lot of my viewers, and that I'll take a quick moment to answer that here. So some people have asked me to put like blowout plugs, like around here, and they say that's because in the case of a catastrophic detonation, the explosion is fairly close to your face, so you want blowout plugs to cause the pressure to move in a direction other than your face for the safety of the user. So I did a bit of research on this. Desert Tech has it for their MDRX, but they removed it on their Wolverine. I don't really know the exact reasons why, but I can speculate because it didn't really work. So in my design, the lower is made out of polymer, so if it does explode, the upper receiver will probably act as a cup, and then the explosion will move in the direction of least resistance, which is going down. So you'll probably just blow out the polymer lower, and your face is, not going to really be touched by it. Also, the chamber is further forward than most Bullpups because of the downward ejection system, so that also helps as well. I spoke to another engineer about the blowout plugs, and he's mentioned that having a hole here with like rubber plugs is actually probably even worse than having it with, covered with metal. And the reason why is because I think this is still fairly close to your eyes. If that thing goes out, it's probably, directing that blast closer to your eye than, say if it just blew straight down. So I believe that the blowout plugs are not necessary, and I will not be adding them because it just makes it even worse. Also, the charging handle is made out of stainless steel, so this is not going to be, this is going to contain the blast downward as well. It's also sort of like in a upside down, like C shape. So yeah, if you got any other additional questions, please just leave them in the comments. I'll try to answer all of them. So yeah, please just like and subscribe. Thanks for your patience on this. I'm getting a few more parts remade, so hopefully I can have this thing done for you guys soon. Thanks.